Let's talk about the invisible engine that's running pretty much our entire digital world, the database. It's this silent, incredibly hardworking system that makes sure everything you do online, well, it just works. So let's pull back the curtain and see how it's done. I mean, really think about that for a second. You might deposit a check, grab a coffee with your debit card, and pay a bill online, all in the same hour. And yet somehow, your bank balance is always exactly correct, down to the very last penny. How on earth is that possible? Or here's another one. You're watching a show on your TV, you pause it, and then you pick it right back up on your phone an hour later, at the exact same second. That isn't magic. No, it's actually the result of some seriously clever design. And behind all of this everyday magic is the database. It's a system built on a foundation of really clear, really smart rules and structures that take what could be total digital chaos and turn it into the seamless order we all just expect every day. So before you can store even one piece of information, you need a plan. You need a blueprint. And, just like building a massive library, designing a database all starts with that master plan. This is absolutely the most fundamental step, right? Because imagine a library with no catalog, no system at all, just books thrown into giant piles everywhere. It'd be a nightmare. You would never find anything. Well, databases solve that exact same problem, but for our digital information. The very first part of that plan is something called the data model. Think of this as the big picture idea. Are we going to organize our data in super neat tables, kind of like a spreadsheet? Or is it better to store it like a collection of flexible documents? This one high-level choice pretty much determines everything else that comes after. So once you've picked your model, then you create the schema. If the data model is the concept of a card catalog, the schema is the actual catalog itself. It has all the specific rules for what info goes on each card. Author, title, publication date. It's the nitty-gritty practical layout. And here we can see two of the most popular blueprints in action. On the left, you've got the relational model. It's just like a perfectly organized spreadsheet. Every single piece of data has to fit into a strict row and column. This is perfect for something like financial data, where you need that rigid consistency. But then on the right, you have the document model. This is way more like a flexible filing cabinet. Each file or document can have a totally different structure, which is great for things that change and evolve, like user profiles on a social media site. Okay, so we've got our blueprint. Now it's time to actually build this thing. How do these abstract plans become a real functioning system?
Well, the first thing to know is that a database isn't just one giant blob of code. It's really more of an architecture, a team of specialized components all working together. Just like a library has librarians and shelving systems and a checkout desk, they all have their own job to do.
And in this system, there are really three main players. You've got the query processor, which is like the head librarian. It understands your request and figures out the fastest way to find the info you need. Then there's the storage manager. That's the vast physical shelving system that knows the exact location of every single piece of data. And finally, you have the transaction manager. This is the strict gatekeeper, making sure every single change made to the library's collection follows the rules to the letter. And that brings us to what is maybe the most critical piece of the whole puzzle, the rules of the library. How does a database absolutely guarantee that your information is never corrupted, never lost, never made inconsistent? The core idea here is something called a transaction. Just think of it like a single complete operation, like checking a book out of the library. You can't just walk out with a book. The librarian also has to update the system to show it's gone. Both of those things have to happen together. If one fails, the other can't happen. It's all or nothing. And here is a perfect real-world example. The second you click Buy Now online, you're kicking off a transaction. The system immediately checks the inventory, then it processes your payment, and finally it updates your order status to confirmed. All of those steps are part of one single logical unit of work. But, and this is the most important part, what happens if your payment fails? The system doesn't just get stuck halfway through. No, it cancels the entire transaction. The item goes right back into inventory and your order is never actually placed. This all-or-nothing rule is what stops all those messy errors, like, getting charged for an item that was actually out of stock. So this is the million-dollar question, right? With potentially millions of people all clicking buy at the very same moment, how does the system possibly keep perfect order and avoid tripping all over itself? Well, the answer lies in a really powerful set of guarantees. They're known as the acid principles, and it's basically a four-part promise. A is for atomicity. That's our all-or-nothing rule. The whole purchase works or it completely fails. C is for consistency, which just means the data always has to follow the rules. For example, you can't buy something if you don't have enough money. I stands for isolation. This means that even if a million transactions are happening at once, they don't interfere with each other. Two people can't buy the very last concert ticket at the same time. And finally, D is for durability. This guarantees that once your purchase is confirmed, it is permanent, it's saved, even if the entire system crashes a millisecond later.
Okay, so we've talked about blueprints and architecture and rules, but why does any of this technical stuff actually matter to you in your daily life?
It matters because every single time you use a digital service, you are putting your trust in these principles. You trust that the money you send will actually get there. You trust that the flight you booked is actually reserved for you. That trust isn't just a given. It's built on the solid foundation of a good database. Seriously, just look at this list. From the integrity of your bank balance to your online orders showing up, from your social media feed loading just right to your airline reservation being held safe and sound, all of it is possible because of the reliability of a well-designed database. And that really gets to the core of it. You know that seamless Just Works experience you have online every single day? It is anything but an accident. It's the direct result of decades of brilliant, careful engineering. Like the quote says, reliability in the digital world is not an accident. It's a result of deliberate, careful design. So when it comes down to it, databases are the invisible engines of trust. They take this potential chaos of just unimaginable amounts of data, and they create order, consistency, and reliability. And that allows us to build this entire complex digital society right on top of them. Which leaves us with one last thought. Our entire modern world is built on this foundation of organized data. But the amount of data we're all creating is just exploding. So what happens when it starts to outgrow our ability to organize it? That is the next great challenge. And it makes you wonder what the databases of tomorrow are going to look like.